Question 7. We see a lot of elaborate house decoration at this time of the year. In a bowl of snowy acres, a large city in Alberta, we found 340 randomly selected, 198 of them put lights. In Frosty Heights, 450 selected, 303 of them put lights. They give you the sample proportion of both of them, also called the observed proportion. They give you all the information. Question A. In context, discuss an independence assumption. What independence mean? Addressing the associated randomization success failure, you don't check. You don't need to check success failure. I told you earlier, when they ask for independence, both samples must be selected randomly. And they are. If you look at the question, they tell you in the beginning 340 selected randomly, and then 198 randomly. So for the second one, 450 randomly. So both selected randomly. Assumptions met. Yes, they are. Condition met. State the hypothesis. Don't need to define the parameter. The hypothesis is, if you read the actual question in line 4, do they differ? The question is asking for, are they different? The two proportions. So here you say, they're not different, so the difference is 0. Here you say they are different, so the difference is not 0. This would be not different. This would be different. And that's, as I told you before, that's the only time we treat it as a two-tailed system. What's the meaning of P2, for example? I told you the standard meeting, P2 is for the second city, Frosty Heights. So P is the true proportion of all houses, true proportion of all houses in Frosty Heights that are decorated during the Christmas time. Population proportions, Frosty that put out lights, yeah, D is the answer. True proportion or true population proportion houses in Frosty Heights that put up decorations. The value of the test you see in Minitab. It's always the Z, you look for the Z letter. And according to the table is -263. Give the conclusion in context of the problem. I'll erase this. We go back. Did they give us an alpha to do this? Did they say do it at a certain alpha? No. There was no alpha given, so we have the case of no alpha. We have to base the conclusion in E, base it on strings. No alpha given, which is significant level. So we start saying since assumptions hold or satisfy, your p-value given in Minitab 0.09. So that's less than 1%. And that sheet that I told you about, strength and significance, this one would be very strong evidence to support HA. So you say we have p-value of 0.009, less than 1%. Very good evidence for HA. But instead HA, you say what HA is, for that the proportions are different. So we have good evidence to support HA that the proportions are different. If you want to add more, you say the proportions of houses in the first city and houses in the second city that are decorated different. Now the last question in this one, if you can to construct 90% confidence interval for the difference, would the value Z be N or not N? Okay, this is F. Remember, we concluded we have H0, HA. We concluded that they're different. Different because we said this is different, this is not different. In this case, 0 is not within. Anytime you, confidence interval, anytime your conclusion they're different, if you have difference, 0 not included. If they're not different, 0 would be included. This is it for long questions. Now all the other questions are short answer question, multiple choice. Shouldn't take long. They tell you people are using web browsers to browse the internet. So they give you the web browser and they give you probability. They tell you Explorer, Firefox, Chrome, and other. And they give you the percentages, 9%, not given, 60%, and 8. Find the probability of the one missing, FF. This is the only one missing. I know they all add up to 100%, so it would be 1 minus whatever the total is. And you do the math, that's 23%. Find the probability that you selected one user, remember, this is only one that likes Explorer or Chrome. Probability 1, Explorer or Chrome, you add them. To this, that would be 60%. 69. If they tell you Explorer and other, you would add them. C. If you select 3, now you're selecting 3. What's the probability they all like Chrome? 3, all Chrome. You take the 60% times 60% times 60%. And that would be the answer. If they tell you you select 3, 2 of them Explorer and 1 Chrome, it would be this times this times this. 3, all of them Firefox would be 23, 23, 23, extra. What if they tell you 3, not all Chrome? So what's the probability that not all of them like in Chrome? It would be 1 minus the previous answer. Because if this is the percentage of all liking, then if they ask for all not liking, it would be 1 minus. They usually ask it, the not, after doing the positive one. So you do this one, and then they'll ask you to the not, then you go 1 minus. Okay, question 2 in the multiple choice. A study compared proportion of American men who order vegetarian meals when eating out with the proportion of American women. Do they differ? They found Z to be 2.71, p-value to be 0.068. What's the interpretation of p-value? Interpretation of p-value is standard, assuming is true, assuming A0 is true, we have whatever the percentage is, probability of having a sample as extreme as the test. So in terms of percentage, this is 68%. And in terms of H0, you see what we say, what H0 is in words. So H0 would be, remember, not different, different. So assuming that men and women are not different, we have 68% to have a sample as extreme. So the answer for this, if the proportion of the American, the answer is wrong. I'll tell you which one is the correct one. They were in the same. Yeah, it should be B. The answer here should be B. Because again, the meaning of p-value, assuming A0 is true, the probability of having a sample as extreme as the one at test equals p-value. So assuming an H0, not different. Not different meaning the same. They picked the opposite. They picked F, but it's supposed to be B. Okay, question 3. They divided people into age, 17, 20, 21, 24, 25, 28, 29, older, and some of them full-time, some part-time. How many part-time students? So part-time, you would add everything in the part-time, 8 to 30, to 22 to 15, that's 75. So part-time students are 75. What percentage of them, of those part-time, remember, when you do probability, you need to know what you're selecting from. So you're selecting from the 75. How many of those 75 you're selecting from age 25, 28? According to the table, 22 of them are within their range. If you do the math for this, 2933, or 29%. What percentage of full-time? Of all full-time, you're selecting from the full-time 2 to 5. 2 to 5, how many of them in the range? 27. So it'd be 27 over 2 to 5, and the percentage here is 12. But if they say, what's the probability of all, from all that are 25, that's a different story. In this case, extra, percentage of all in age 25, 28. In this case, all you would divide by 300 because that's everybody. And the age 25, 28 would be the 27 and the 22, both of them over 300. And the D question, does the data depend on the status? Do they depend on each other? If these two numbers that you calculated, full-time and part-time, but the same thing, age 25, 28, age 25. Since these two numbers not equal, then they depend on each other. If they equal, they don't depend on each other. So yes, they obviously, of course, depend on each other. Okay, we keep going to question 4. A researcher wants to know the proportion of international differs. Differs, I told you, not equal 210 right away. And they found Z to be, from the test, 0.3. What's the p-value? And I believe they did something wrong in this one too. I told you, remember in the previous question, the 4 cases of p-value? I believe this was case 4 or 3. I don't know how I put them. But this is the case when HA not equal and Z-test positive. You'll see it in one of the questions earlier we did. If that's your case, it's 2, 1 minus table. So you go to the table in the last page and you see 0.3. What's the percentage that corresponds to 0.3? Just grab it here. O3 from your table would be 5.2, because you have to look for 0.0 and the second decimal place is 3. You see it pretty much in the same line, first line, sorry, 5.2, 5.1, 2.0. 5120, so it's 2 times 1 minus 5120, and that will give you 976. So that's the answer for the question, 976. Which is number F. I don't know, they used, they circled E. E has nothing to do with this. The answer is F, obviously. Question 5. This question always comes in the midterm, and the answer usually all of them false. So I don't know. I don't really need to explain, because usually it's a typical question, and usually if you see it, it's all false. Question 6. Confidence interval for the difference between British and Canadians who read at least one book in the last year is between this and this. Now, the standard way to talk about confidence interval difference, you see the first number, 9.3. You circle it, and it's lower. Okay, I'll tell you what they mean by the question so that you're not confused. So it's question 6. They tell you, what would you select for this? 9.31, lower, higher. And then 9.31, and also lower, higher. And your confidence is given between this. So that's the first number, and the negative means it's lower. This is the second number, and positive means lower. It could be both negative, so lower, lower, depending on the situation. Now, question 7. Researcher asks question 7, and I believe there's also a mistake in this one. A researcher is studying the possible effects of vitamin A and C. So 2 vitamins, A and C, on health. There are 100 subjects participating, so 100 people going to participate in this. They randomly select to get a dosage of 0 of A per day, or 250 or 500. So the doses for this either 0, 250 milligram, or 500 milligram. For dosage is subject to randomly, for each dosage group is subject to randomly select 0 vitamin C or 400 vitamin. But vitamin C has 0 and 400. So the first one has 3 different dosages, this one has 2. After 1 month, the subjects are meant to receive the health rating between 0 and 10. So, first of all, how many factors? Factors would be the 2 main things. Before you do into subgroups, the two main groups would be your factors. So you say 2, vitamin A and vitamin C. How many treatments? Oh, this is the mistake. There are 2 dosage here versus 3. So treatment is 5, not 6. Maybe they thought that it's 3 for both. No, it's 2 and 5, so they're 5. 2 and 3, 5. Response at the end, what do we get from this? Their health rating. Yeah, health rating, because they're going to leave them for 1 month and then measure the health rating. And what's the experiment unit? Would be the unit of measurement, in this case would be the 100 people selected, or the 100 subjects selected. Question 8. I don't think I need this anymore. They give you a box plot. I'll do it quickly. Starts this number here at, again, it's not very clear, 28. This number here at 26, this level. Then we have this one at 25. This one at 22. I believe this one at 17. And there is a star here. And the star looks like is at 15. Remember, in the actual rectangle here, that would be Q1. This is median. And this is Q3. From this up, from 26 to 28, 25% of the people. From Q3 to median, 25%. From median to Q1, 25%. And from Q1 to the beginning is 25%. This is basically what this is. Remember, they tell you in the question 8, that this is based on 60 participants. So you have 60 participants. What's your IQR? IQR is Q3 minus Q1. 26 minus 22, 4. State the value of the lower fence. Lower fence is Q1 minus 1.5 IQR. If they ask for upper fence, it would be Q3 plus 1.5 IQR. But they only ask for the lower fence. Q1 is 22, 1.5 times 4. That would give you 16. And then question C, how many of the participants between 26-28? 26-28, that would be 25%, so answer for C, that would be 25% of 60. That's 15 students. And if they ask what the percentage for those between, say, 22 and 26, that's 25, 25, 50% of 60, 15 students. So, a straightforward question. And again, question 9, they give you the graph, and they tell you which of the following is really violated of those assumptions that we know of. The first one, a straight line, you look at this graph, and yeah, a straight line. They can assume a straight line close to them, so the first condition is good. Outlier, do you see a lot of points far from the line? No. If it's 1 or 2, okay, but not a lot of outliers. In this graph, there isn't any outlier. Does the block thicken? I don't know if I agree with this. You look at the graph, you see there are 4 graphs here. One of them has a line. In this graph, if the points are spread evenly, meaning that it's not like concentrated on one place and like that, this is bad. This means if you see it this way, then you say, yes, it's this condition that the clock thickened. But here, if you look at it, they spread evenly. There is no concentration in one area over another one. The two things that's left, nearly normal and randomization. Randomization you can't figure out from the graphs, I'm not going to talk about it. Nearly normal, look at the histogram, this graph. You see, it looks like this, something like that, so it's all over the place. It's not symmetric, it doesn't look like this. So this is the one that should be violated. The histogram is multimodal, it doesn't show enough information, so the answer for this would be D, not C. Now this is it for the exam. Study this, make sure you understand everything. If you have a question, you can text me. What also I'm gonna send you, I'm gonna email it to you, so hopefully you sent me your email. I'll email you the actual exam. And make sure that don't stick to the answer provided. It's usual, most of them are the same, but there are some mistakes they've done. And I'll send you the other one too. Good luck.